Hello everyone, today we're talking about a new solid-state battery shown by Finnish company Donut Lab. Their first video was packed with data and looked very impressive, but 2 weeks ago they released test results. To an average person they seemed okay, but battery experts were not impressed. Because of that, the initial excitement has started to fade, so I thought we'd go through the data to understand what it actually shows. The company promises big things like a high energy density of 400 watt-hours per kilogram. For context, high-density batteries in today's electric cars are usually around 300 watt-hours per kilogram. If this claim is true, it would be a major leap forward for the entire industry. Let me know what you think in the comments. Will this be the battery revolution we've been waiting for? Right now, very good high-density batteries, like the ones used in electric cars, are usually around 300 watt-hours per kilogram. So if this claim is true, that would be a big improvement. They also say the battery could last about 100,000 charging cycles, which would be incredible. And they say the battery could charge extremely fast, even reaching a full charge in about 5 minutes. That all sounds amazing, but we have heard similar promises before from companies working on a solid-state battery. And many of those companies have not released a real product. Yet this company says they already have the battery, and they showed some test data where a Finnish tested the battery. However, after watching several expert discussions about the report, most of them seem to have the same opinion. The company did not just give the battery to a lab and say test it however you want. Instead, they told the lab exactly which tests to run. In total, only 7 tests were done. And in the report, the lab also clearly says that they only did the tests exactly the way the company asked them to do the lab. Also said that the company claims it is a solid-state battery, but the lab itself did not confirm that so right now. There is no clear proof about that part. Experts also looked closely at the charging curves and the data like voltage and current. According to them, the results do not look very special. They say the curves look very similar to what we already see in a good modern lithium-ion battery. One of the tests showed that the battery cell was charged at 11C the C rate, is a way to describe how fast a battery charges if a battery charges. It means it goes from 0 to full in about 1 hour. At 2C, it would charge in about 30 minutes. At 5C, it would charge in about 12 minutes. And at 11C, it would charge in about 5.5 minutes. The data showed the battery was charged at around this level. But the actual time in the test was closer to about 8 minutes instead of about 5 minutes. Experts say that is good, but it is not something extremely special. Another issue is that the battery was only charged a few times during the test in total. It was charged only 7 times, and only 2 of those charges were done at the very high 11C rate. Because of that, the tests do not really show how the battery will behave after many cycles. This is important because with a normal lithium-ion battery, if you charge it that fast, many times it will quickly lose capacity and energy. Another number experts looked at was efficiency. That means how much energy goes into the battery compared to how much energy comes back out in the test. When the battery was charged and then discharged, the efficiency was about 92%. That means if you put 100 units of energy into the battery, you only get about 92 units back. Experts say that is actually very normal for a lithium-ion battery. But if this battery was truly something revolutionary, some people expected the efficiency to be closer to 99%. So again, the numbers did not look very special. Temperature was another topic in another video. The battery was charged while it was around 100 degrees Celsius. It had 2 steel passive cooling plates attached to it. But there were some problems during the test. The battery lost its vacuum, which means a small hole appeared and gas escaped. That is not a good sign. This kind of thing can happen with lithium-ion batteries because they contain liquid electrolyte in a real solid-state battery. This should be much less likely. It does not automatically mean something is wrong, but it is not a good look. Another person also calculated how much cooling would be needed if this kind of battery system was used inside an electric car. The results suggested that the cooling requirements would be extremely high, and most electric cars today do not have cooling systems strong enough for something like that. The company also said the battery can work at temperatures between 90 and 100 degrees Celsius without losing capacity. Experts say that actually also happens with lithium-ion batteries. When a battery is hotter, it can temporarily deliver more capacity. The real question is whether the battery can survive that heat for a long time. Lithium-ion batteries usually degrade if they stay too hot, too on, and the tests did not show anything about long heat. A Another claim from the company is about energy density when people tried to estimate the density using the size of the test pouch cell. The number came out to around 700 watt-hours per liter. That is actually quite normal for a lithium-ion battery. Some people also tried to estimate a weight-based energy density, and it came out to around 300 watt-hours per kilogram. Again, that is very similar to current lithium-ion batteries. The company claimed 400. But maybe this was just an early test cell, so some people say it might change later. There was also something called coulombic efficiency, which helps estimate the lifetime.